now let's go to the calculation part of this electromagnetic forces, blah blah blah, so and so, right? Okay. Now, before going that further, we need to introduce formula aside from the electric force, right? We need to introduce a formula that involves, magnetic field strength. How can we compute the magnetic field strength? It's gonna be like this. B is our electromagnetic or magnetic field strength. N, F, S. Okay? Magnetic field strength. Ganon. Is equal to the magnetic permittivity, like epsilon O. So, NP, magnetic permittivity, ganon. Okay? Times the current, I in ampere, over the circumference as it travels to the circular path. Okay? The elementary particles, so this is 2 pi r. This is the first equation of magnetic field strength. So, investigate the units. Magnetic field strength is going to be ampere per meter. Okay? Magnetic field strength. And then our EO will be, this is magnetic permittivity or permittivity through space of the circular path covers by this force of attractions. Okay? Something is going to be 4 pi times 10 to the negative 7. Okay, this is going to be Tesla ampere meter. Wow, complicated, right? This is the ampere meter or Newton ampere meter. Okay, there's current, right? Because there's ampere in the denominator and there's no ampere in the numerator. Okay, it's related to electric forces talaga siya, guys, or electromagnetic forces. Okay, radius in terms of meter, you don't have to worry. Okay, pi is 3.1416 in case you don't have calculator. 3.1416. I is current based on electrically charged particles or the movement and flow of electrons. So this is ampere, right? So with this, bingo, you can solve what is being asked. Now this is a little bit of complicated compared to the simpler one. Okay, which have also, for example, we have magnetic field strength. Okay, H. Okay, magnetic field. Take note, the magnetic field strength in this first equation is denoted in B. So to make not to confuse, put this as an H also, because they are also the same magnetic field strength. Because you pick up the two other references and they don't have the same declaration of the symbol or the letter. Okay, like that. So magnetic field strength is equal to the magnetic flux. B is constant. Whatever sources you have, different books, the magnetic flux is always capital B. Okay, over this one, magnetic permittivity or the permittivity through free space. Ganon. EO. Okay, you don't have to worry over the EO because you know already the unit as mentioned a while ago. And then magnetic field strength is mentioned also a while ago. But you don't have the unit of magnetic flux or magnetic field. Magnetic field or magnetic flux density is just the same. Okay, so magnetic field. Magnetic is more on general. Okay, but this is also known as magnetic flux density. Sometimes they dropped the word density because it would mean only the magnetic flux. But sometimes also to make more precise, magnetic flux density. So things like that always the same connotation, meaning understanding. Okay, magnetic flux density. Okay, because I love to be precise, that's why I put density, right? And that's the unit will be kilogram second squared ampere or Tesla. Okay, or Weber per square meter. Now we have the second option 1 and 2. Okay. Now if you notice in your problem, guys, it will be combined. So use also electrostatic force, electric force, using the Lorentz law. Lorentz, a combination of the electric force and the magnetic force. Okay, something like that, and the magnetic field. Okay, so it's gonna be Lorentz law. It's gonna be phi b. Okay, these forces, electromagnetic forces, is equal to the charge of your electric field coming from your electric force. So QE, okay, plus the charge coming from your magnetic force. okay, which is corresponding to the velocity. So times V, then times the magnetic field. Ganon. This is equation number 3. The equation number 3 is more comprehensive and complete, but most of the problems will eliminate the first term 3 because there's no electrons being moved from one point to another, only magnetism involved, and sometimes also there's no magnetism involved, only the electric force are moved. It depends on how the way you analyze the problem. Okay, sometimes also it's very rare cases that they will go together. Okay, usually there must be zero here. The first term, second term, first term, like that. Okay, so, but this is the comprehensive and detailed formula of electromagnetic forces. Then if we drop the electric force here, it will not become magnetic force only. You will drop also in your terminology the electro. Okay, because this is electromagnetic force. And then if the problem was saying only electric force are being mentioned there involved in your problem, then you need to drop the magnetic. You will say electric force is equals to, because you dropped in your equation already. Then the reverse also will hold through. If there's no electric force involved in the problem, you can feel that technically based on the data given. Then you will say also magnetic force. Then dropping the QE equal to 0. Things like that, okay? Then number 4, what else? The equation number 4 will be pertaining to, centripetal force involving mass. We have Fc is equals to mv squared over r. Okay? Then in terms of charges, it will become, again, over and over again. I repeat this a trillion times. Fc is equals to k q1 q2 over r squared. And you can do a lot of derivation in bingo. Okay, you can solve for radius or distance covered in a circular path. Okay, take note, magnetic field always rotate in a circular path. Okay, get the point? That's the difference between the electric field. Electric field not necessarily to rotate, as long as they will interact directly in opposite direction. But this magnetic field, igat kaayo bigaon. He will rotate in a circle. Charot. Diba? Murampag yun siya. Okay, bisag naragari, murang tuyot pa yun siya. Diba? Bigaong kistanan. So, the electric force are only attracting directly, but this magnetic flux will solely usually sa rotonda. Something like that. Okay, that's the analysis of magnetic field and electric field. We need to put this in this way so that we can understand. Okay? So again, magnetic field, bigaong kaayo, he will rotate on a circular path going back to the stationary point, destination point. And then this electric force of attraction, electrical charge particle, no need. As long as they react with each other having an opposite electrical charges. Something like that, the positive and the negative. No need to tuyok-tuyok dito sa kuan. Okay? Ditso yan. Pilit. Ganon. That is electric field. Get the points that we can understand in the context of our discussion. Okay. Now, okay, is this enough? Yes, I think this is enough. Yeah. Now, if we involve angle of inclination, just add sine theta here, sine theta here. Okay? Why? Because sometimes it will rotate in an angular momentum. Something like that. Specifying the problem is 30 degrees of electrons. Then you need to consider the angular inclination. Then you have to put the sine theta. So why sine theta? It is coming from the law of right triangle by Pythagoras theorem. It creates a right triangle, something like that. Okay, you remember that one? C squared is equal to A squared plus B squared. C stands for the hypotenuse, B stands for the, the opposite side, and A stands for the base. Ganon. That's why you have this one. After this is sine theta, is equals to the base over the hypotenuse. Ganon. Hypotenuse is equals to the base. Since this is the hypotenuse here, okay, here, there's a hypotenuse here. So you multiply this with sine theta. Okay, because your V always the hypotenuse. Okay? Your V covered is always the hypotenuse. That's why V sine theta. Okay? To the point, it will create a diagonal. Anong guna siya, guys? So, V, ganun, F, V, ganun, and then this V will move, move siya, ganon, going to circular path. And the force also will rotate, going to the center of the circle. Ganon, big circle, small circle. Ganon. So, ano siya may tago na higayon niya. Okay? So, pwede na dito mo calculate. Chop. Okay? So, ganon. And then the direction here is very important, ha? Okay. For example, from north to south, south to north, upward, like that, downward, and then left to right. Okay? So, I need to research on the spot problems here in the, in the Wikipedia. Wikipedia ba siya, guys? Wait. Okay. Because I don't bring books. Okay? How can I do that? Okay. So, di ko makabuhat kung problem kay lisod-lisod mo siya, guys. Okay. Not really that lisod. It looks like a little bit, ano ba? You know what I mean? Okay? Okay, like that. Okay. This one. Okay. Ani ang kita karon. Okay. A current of 15 ampere, like that. Problem number 1. Okay. Current naman with soup. Okay. A current of 15 amperes. Okay, ano yan? Flows south. Wow. Flows south. Okay. And then, what's this? Through altimeter wire. Through a 2-meter wire. So, plano na kayo, nagisan siya. Okay? 2-meter wire with a magnetic field of, wow, with a magnetic field of, sa'yo na siya, guys, kaya namin mga gamitin ng magnetic field of 10T. Take note, guys, ha? You should also be clever enough that the topic is more on current. The capital T here is not the tension force. It's not also ton. Diba? Conversion. Let's recall our, high school math of conversion. Diba? 1 ton, 1 short ton is equals to 2,000 pounds. Okay. Or equivalent to 1 metric ton. Okay. We have also 1 long ton or 1 long metric ton is equal to 2,200 pounds. That's the difference between a long ton and a metric ton or a short ton. Now, if we are trying to use directly the standard in English unit, we don't have to worry because if we mean 1 ton, that's only 1 short ton or 1 metric ton unless otherwise specified in the problem. Okay? That's why when you solve the problem, things like that about ton, it's understood that you will use a conversion of 2,000 pounds because it is understood to be a short ton or a metric ton in English, something like that. So, universal interpretation. Otherwise specified, you will say 1 long metric ton, like that, you will answer with 2,200 pounds in your conversion. This is only another, introduction. Maybe you will be tricked out. Something like so. 2.3 long metric ton. Instead, you are using the 2,000 pounds. So you will know your answer because you did not follow the conversion, the precise conversion between a long metric ton to pound. Okay, like that. Dito po mga palangga, muna siya may tabo. 1 pound is equal to 454 grams. Okay, ganun-ganun, di ba? Okay. 1 pound, 1 kilogram is equal to 2.2 pounds. Mo ba? Basta sure ko 1 pound is equal to 454 grams. Okay, wait, 1 kilogram, I think 1 kilogram is equal to 2.2 pounds. Okay? Anyway, we can convert that from pounds like that. So based only in my memorization, maybe I was wrong. Okay, something like that. So capital T here is Tesla, ha? Not the ton. Okay? You can talk about not also the tension. Okay, to make it understood that this is the magnetic force topic. Okay? Tesla meaning magnetic field. Okay? Or magnetic flux density. Ganon. Okay? Directed out of the page. Wow. Directed out of the page. And then, yung timanang nasa may honey page, shuba chuchu. And this is also magnetic force. Okay? You need to remember the clue and the hint. So that when you encounter that one, you're gonna apply that specific formula. You should not think so many equations on your minds. And then, maglibog man ka. So, we need to extract the hint, H-I-N-T, the clue, C-L-U-E. Okay? The identification, the direct identification that is gonna be applied to a certain equation and formulas, this type of problem, things like that. Okay? You get the point. Okay. What is the magnitude? What is the magnitude? Nakakaloka. What is the magnitude? Okay. Mga palangga. Kumitan. What is the magnitude of the force? Okay. What is the magnitude of the force per unit length? Okay. Magnitude of the force. Mo ba? Force per unit length. Na guys, uwin hadlock na ko. Charge! Per unit length. Ikalit talaga niya ang length. Okay, let's analyze. Okay, like acting on the wire. Acting on the wire. Okay? Laoy. It's gonna be na-length siya guys. Ako mga discussion or ba ito yung length? Ako lang i-connect. Diba sa mga theory? What I emphasize, there's a turn length here. Okay? And there's also 2 meter here. It's gonna be two different quantities. If we assume this as a distance, and the length is also here. Take note, in our formal discussion, we don't even touch the length. And we need to derive. Right? How can we do this later? Ay! Pinahirapan yung sarili. Okay, a current 15 ampere. So, current I. Okay, 15 ampere. And then, flows south. Going to the south, meaning it's going to the downward. Okay, meaning negative current. For the purpose of direction. But it will never carry the sign of the magnitude. Meaning the figure, the number, will never carry the negative. Only the direction where it goes. Something like that. Okay? And then, through a 2 meter magnetic field. 2 meter, this is gonna be the R. Okay, R, 2 meter. Right? Mga pinagkakulitan? Yes. Okay, 2 meter. Ganon. With a magnetic field of 10 tons. This is gonna be the D. Tesla. 10 Tesla. Magnetic field. Directed out of the page. Out siya guys, meaning to say, it will going clockwise. It's be away from the page, not going to the page. This is the page here, the wire. Okay, the unit or the surface of the wire. So I will put the wire here, ha? Okay, wire. Let's cut the wire for the purpose of calculation. Okay. And then, what is the magnitude of the force? Ganon. What is the magnitude and the force per unit length? Kaloka? Laoy. I feel difficult. Charot! Sige lang, itry lang dito. Okay, so force. Okay, ganon. And then, away of the page, 10 tons siya. Tesla naman. So, like this. This is now our magnetic field B. Now, it will covers velocity going to the right? Wait. Yeah. So the velocity going to the right. Okay, like that. To the left, and then it will reach somewhere in the central point. Okay, your FB. This is your FB. Ganon. FB, ganon, velocity. Okay, velocity. No, outside man siya, yung velocity going to the left, sorry mga palangga, kay out from the page man. So, it will go there, and the velocity also will go there on the left. And then your V here, and then this is your FB. Okay, and then mutulog na po siya. Okay, and then ganon, the V will be upward and the FB will be go to the center. As long as the magnetic force will always be on the central point of gravity or the centroid, that is the purpose of the velocity. Always perpendicular with each other. Okay, 90 degrees. Now, how can we solve this? So we have the formula of katungkang Lorentz law, right? F B is equals to the charge of electric force. Guys, there's no attraction here. There's no positive and negative here. So we treat this as a zero already because there's no pole, positive pole, negative pole, but charge. So zero. Okay. So this is gonna be ano na siya, magnetic force na siya. Magnetic force, kinatagap ng electric force sa Lorentz law equation. And then we have the charge. Q times V, velocity of the magnetic force. Okay, then times the magnetic field natin, magnetic field. Okay? Yung natay ko velocity na ba? Wala. Wala, Jude. Ay, kagul. Charot! So, FD is equals to, nasa tayo charge ng bigay yun na. Wait for a while guys ha. Wait, what is traveling here? First, it's gonna be an electron will travel here by default. If it is not mentioned, what I understand guys if that is not mentioned as a proton, neutron, photon that will travel in the wire, that's understood to be the electron Normally, electron naman talaga reality. Electrons flow. So, ganon. Mahatag na talaga yung charge over dito. No, let's say charge niya is of an electron. It's gonna be 1.60 times 10 to the negative 19 coulomb. Right? Natin charge. O, at may pasok na rin. Natin Q. Check. Okay? So, we don't have the V. The velocity is meter per second. Okay? Let's say, substitute 1.60 times 10 to the negative 19 to simplify further. Okay? So that we have a less quantities to try to find out. Okay, velocity is nothing. Magnetic field is here, 10 Tesla. So we don't have the force, we have also the velocity. So this is circular path man siya guys. Okay, so we will cover the mass and the squared over r, right? And then 1.60 times 10 times 10 to the negative 19 velocity, right? We have the mass of an electron, which is 9.109 times 10 to the negative 31 kilogram. This is the mass of an electron. We should memorize also the masses of the particle because this is our constant. 9.109 times 10 to the negative 27 kilogram. And then we look at the velocity. Opposite, left and right cancel the other velocity on the other side. So what we left is only the V mass. We have the radius.